Hello, everybody. Thank you for coming. My name is Rafael Zambrano. I'm the head of data scientist at LaLiga Tech, which is the technology company of LaLiga, the football competition in Spain, or soccer here in America. So we're going to talk about technical and tactical football analysis, how we use data in order to develop new metrics, new interesting metrics, and also the goal probability metric, which is the first predictive metric that we implemented this year. Before I started, let me show you a short video. What's the probability that I score this goal? I'm going to ask you some stuff during the presentation. I don't want to be here all alone, so please help me out. What do you think? What's the probability? 40. OK, 43. In this case, we don't need machine learning. We don't need artificial intelligence, because the answer is very simple. Who knows? It's not working. Last chance. It's not working, but the probability in this case was 0, OK? But when we're talking about professional football players, there is an actual probability, OK? And this is the metric that we have developed this year. At the end of this presentation, we're going to talk how do we get to this percentage, to this probability. So do you like football? Do you like soccer? Yeah? Well, then probably you will like this speech. I will talk about what data do we have, how do we prepare this data, and some interesting use cases, new metrics, and finally, we'll talk about the goal probability, this metric that we have just implemented this season. So what do we have? On the one hand, we have event data. Okay? We have all the events that happen in every match, all the passes, all the goals, all the clearance, the saves, the shots, the penalty kicks, the cards, the injuries, the corners, everything. Everything that happens on a game, we have this data. Do you think this data is captured manually, or this is something automatic? Do you think there is a guy tagging every single event in a game? No? Yes, actually, the technology is not enough advanced, so there are actually 2 people tagging every single event that happened in a match. Not only the event, but also qualifiers for the event. For example, with a pass, can be a long pass, a short pass. They also tag the player that did the pass, if the pass was successful or not. So there's also qualifiers with the events. And this company, StatsPerform, tag them manually with the special softwares and keyboards, and they send us an XML file, big XML file like this one, with all the events that happen in a game. This is the event data. And on the other hand, we have the tracking data. We have special optical cameras in the stadium and collect the position of the player and the ball 25 times every second. So every second in the game, we have 25 times the position, the coordinates of every player and the ball. And we have these cameras in all the stadiums of the 22 clubs that are in La Liga. And this company, which is Cairo, sent us another file like this one. This is a plain text file with more than 3.6 million rows. So for every frame of the game, we have all the coordinates of every player and the ball. So this is a very huge file, which we have to process as well with the event data. So we need to combine the event and the tracking. This is not an easy task. Let me show you how we do this. First of all, we transform the files into tables. The XML file with all the events and all the qualifiers, we transform them into tables, and we create a simple relational model like this one. We have the events, we have the qualifiers, the event types. The events happen on games. The games belong to a competition. The competition has teams, and the teams has players. So this is how we transform the XML file to tables. And we store the files and the relational model in our data lake. And with the tracking data, we do the same. We transform this plain text file into tables with these 3.6 million rows for every game. And then we need to combine the event and the tracking. This is not a simple task because these two sources don't speak the same language. For example, on event, we have for players IDs, and in tracking, we have the number of the jersey. In time, we have timestamps for the events and number of frames for the tracking. We need to combine these two sources time-wise. And also, in the space coordinates, we have different coordinates, different units as well. So we need to modify to process this data in order to combine the event and the tracking. The objective is for every single event of the game, know the position of every player and the ball in order to develop metrics that I'm going to show you in a few minutes. And this is not the only thing that we have to process, because when you tag something manually, you are making a mistake, an error, right? Because it's a human who is tagging the event, so we have errors in the tagging of the events. And I'm going to ask you for help on this one. You are going to see a shot of this player. And in the next repetition, I want you to clap your hands when the player makes the shot. OK, clap your hands. OK, so if you were tagging, as you can see, there is a delay between every clap because it's normal, right? It's not perfect. A human tagging the event, so we also need to correct this. Because in 1 second on football can change everything. So how we correct this frame? We have the tagged shot, in this case, in a particular frame, and we look a few frames before and few frames after. And we measure the distance between the player and the ball. Okay? So when the distance is minimum for the last time is the moment, the exact moment when the shoot took place. Okay? So in this case, we are correcting the tagged shot for the actual shot. And this allows us to implement our metrics with more precision. So this is the process. We receive the event data, the XML files, the tracking data. We stored it in our data lake, all the files, and then we transform them to tables. And then we, in a model layer, we calculate the data. We combine the tracking and the event. And we also send this information to the clubs. So this is the final model. All the data is calculated, and now we can know for every event of the game the position of the players and the ball. So let me show you some use cases. We have developed more than 30 use cases. I'm going to show you only 4 because we don't have time, but you can see these use cases in the website of LaLiga, laliga.com/BeyondStats. BeyondStats is the project that we have developed this year with many, many metrics, combining eventing and tracking. For example, these use cases calculates the opponents passed by a pass. We have statistics on passes, but we don't know, for example, which is the top 1 player in La Liga who leaves more opponents behind when he makes a pass. So in this case, we have the event, the pass, and we have the coordinates because we are combining eventing and tracking. We have the coordinates, the position of the player that gives the pass and the receptor, and we have also the coordinates of every opponent. So we just have to count how many opponents this pass is passed. Okay, so with this, we can generate these events automatically, these qualifiers for the passes, and know, for example, which is the top 1 player in La Liga that makes more or leaves more opponents behind his passes. Any idea who this player could be? Pedri? It's from Barcelona, actually. Let me show you a video. Okay, so we calculate these qualifiers for the passes. We send this information to the clubs, and we also can create content in the broadcast or before the game or after the game in the website. Okay. Let me show you another example. I will answer your questions at the end of the presentation if we have time. I hope we have. Another example, ball carries leading to shot. Okay, in this case, we're trying to detect these events in which a player carries the ball and then make a shot. First of all, we have to detect the ball carries. And how we can do this? Well, it's simple because we have the coordinates of the ball, the coordinates of the player. If they move along in a short distance, we detect the carry of the ball. So we detect this ball carry, and then we have the event of the shot. When we combine event and tracking, we can develop this particular metric. Let me show you the video. Okay, another example, the distance covered after losing possession. In this case, the event is not losing possession, but a ball recovery. But it's the same, just for the other team. So when a player recovers the ball, we measure the distance covered by every player of the other team. Okay, so within the next 5 seconds after losing the ball, we calculate this distance, okay? And we can understand which teams run most when they lose the possession, which teams run less, and try to understand better the performance of every club with metrics like this one. For example, this team is the top one in distance covered after losing possession. Their players cover more distance when they losing the possession. Okay, and last example, the passes into double pressure. As I told you, we have more than 20, more than 30 metrics like this one. You can Google LaLiga.com/beyond stats. And in this case, we have passes into double pressure. It's the event of the pass again. And we measure when the player that gives the pass and the receiver are under pressure, which is they have an opponent in a less than 2-meter radius. Okay, so in this case, we just, again, automatically can detect these particular events when a player makes a pass and he and the receptor are under pressure. Okay, so this was just a few examples in which we are combining event and tracking. We combine them, we develop new interesting metrics. And let me talk to you now about the goal probability. This video that you saw at the beginning of the presentation, goal probability, what is it? Well, the goal probability is a metric that evaluates the chances of a player scoring based on his position and the position of his opponents. And we calculate this metric on every single frame of the game for every single player. So every player in every moment of the game has a goal probability. Let me show you how we calculate this probability. First of all, the data. We receive this tracking data also in real time. These 25 frames every second we receive in real time, and we have to process. Okay? So for every single frame of the game, we have the coordinates, the position of every player and the ball. This is a frame of the game. We have all the coordinates. In the next frame, we have different coordinates. In the next frame, we have different coordinates. And we have these 25 times every second. It's a lot of data, more than 3 million data for game. The second step is to calculate the variables of the model. I will talk about the model in a few minutes, but let me show you first which are the variables that the model takes an input. First one, the most important, the distance to the goal. In this case, it's 18 meters. Also, we calculate the distance to the goalkeeper, the angle to the goal, the angle to the goal. The greater is the angle, the greater should be the probability, right? Also, the number of opponents in the cone of vision. If we draw this triangle, this cone of vision between the player and the goal, we count the number of players. If an opponent is near the cone, it's counted as 0.5. So in this case, in this example, we have 2.5 opponents in this cone of vision. Also, the distance to the nearest opponent. It's an important variable because if you have an opponent near, it's going to make it more difficult for you to score. Also, the angle to this opponent, because it's not the same that he is in front of you or behind your back. So we draw this line from the shooter to the goal, and if the opponent, the nearest opponent, is right in front of you, it would be 0 degrees, and if he is on your back, it would be 180 degrees. In this example, it's 25 degrees, right? So it's more or less over here. If this is a one-on-one occasion, it's not the case. Also, the angle to goalkeeper. It's important to measure if the goalkeeper is good positioned or not. So we just make the same approach as I told you before. We draw this line to the middle of the goal, and we measure the angle of the goalkeeper. In this case, it's very good positioned. It's 1.5 degrees. It's almost 0 degrees. And also the quality of the player, because it's not the same that the shoot is made by Benzema or Messi or a striker, a good striker, or a defender, a midfielder. Okay? The good players, the player that scores the most, should be higher probability. Okay? So this is another important variable as well. So we collect these variables in real time with all this data that is generated also in real time. For every single frame, we calculate these 9 variables. And then, with these variables, we execute the model, and the model gives us the probability. I will talk about the model in the next slides, but this is the main process, okay? Calculating the variables in real time, the model gives us a probability, and then this probability is graphic on the broadcast of the game. So we have the input, the model, and the output for every frame and every player. And finally, we have to send the results to the technicians on the television in order to put it on the broadcast. So we have developed also a front end and an API in which the people from television can select any player, any timestamp, and any frame. As you can see here, we have the goal probability and also the player ball distance. It's the same approach as I told you before. They have to select the exact frame in which the player made the shot. If you see, I don't know if you can see it, but in the next frame, the ball is already 1 meter away from the player. So they select the exact frame in which the player shoots. And this, finally, they put it on the broadcast of the game. So this is the process. We receive the data in real time, the position of the players on the ball, 25 times every second. We calculate the variables also in real time. We call the model, and we send the results through an API. And we can do this first 4th step in less than 30 seconds, okay? I don't know if you think it's a lot, but it's very few seconds, okay? So eventually, they can put this on the second replays of the shots or of the goals or wherever they want, okay? So as I told you, we have a lot of data to process, more than 3 million data for every game, which means 30 million data for every match day. So we need high processing capacity. These have been possible with a multidisciplinary team. We have worked data scientists, data engineers, data architects, also experts of football and audiovisual. And also, we have collaborated with our partner Microsoft, and we have using their solutions. This is the technology architecture, in case you're interested. It's the same as I told you. We use Microsoft Azure in LaLiga. We use Event Hub in order to process this real-time data. We use Databricks to call the model and execute the model. We store the results in a Cosmos DB database, and we send the results through an API. And I told you before about the quality of the player. Okay, we make a clustering here in which we group the players in 4 different levels, depending on the number of goals per game and the number of goals per shot. Okay, so the players in the right up corner are more likely to score, like Benzema or Gerard Moreno. This is Gerard Moreno from Villarreal. They make more goals on every game, and they make more goals on every shot, so they should be more likely to score. And on the other hand, the players that are in the left down corner are less likely to score. They don't usually make goal. Okay, so this is another important variable. The players that are more likely to score will have more goal probability. And what about the model? Well, we need to use historical data to train the model. Okay, we need the model to train from the past. This is machine learning. We have used more than 2,000 games and about 20,000 shots in order to train the model. So for every shot on the pass, we have to calculate the same variables along with the output, if were goal or not goal. So for every pass, goal or shot we had, we calculate the same variables, the distance to goal, the distance to goalkeeper, the angle, the number of opponents in the cone, et cetera, and the output, if this play was a goal or not. And we do this with more than 20,000 shots. So the model can learn every different situation, okay? So since we have combined the event and the tracking, we can do this. We can generate the variables, and for every single shot, the model is going to learn, right? Again, we're combining tracking and event. The event tells us if this shot were a goal or not. So when we do this, when we collected all this data, we end up with an imbalanced data set. Of course, most of the shots are not goal. About 20% of the shots on target are goal. So we have an imbalanced data set. We have to deal with that. And we also need the model to be explainable because we need to explain why a certain probability the model is giving. We cannot say, this is a 3.5 probability because the model says so. No, we need to explain why the probability is 3.4 or 80 or 70, whatever. So we have used logistic regression, in this case, for the goal probability model. We have also tried a more complex model like XGBoost or neural networks, and the performance were similar. So we are happy that logistic regression have a good performance and also is interpretable, like you can see here. With the imbalanced data set, what we have done is to balance. Okay? We create synthetic new samples in order to balance this data set. Okay? So we create samples that never happened but are similar than the goals that actually happened. And then we have our balanced data set with logistic regression, which is a statistic technique that models the probability for classification problems. I don't know if you are familiar with this particular model, but I'm going to try to explain in these few minutes. So in order to simplify the explanation of the model, let's consider only the angle to the goal as the explanatory variable, okay? To simplify. I told you that we have 9 variables, but imagine that we have only the angle. So the greater is the angle, the higher should be the probability, okay? So logistic regression is basically this formula. We have an independent coefficient and the coefficient that multiplies every variable. In this case, it's only the angle. And we have a sigma function, like this one. The sigma function is a function with an S shape, and it goes from 0 to 1. So it gives us the probability between 0 and 1. And we have our data. We have, in this case, many different angles for many different shots, and the result of these shots, if they were goal or not. So we have our data in the 0 and the 1, right? We don't have access to the probability. We can only observe the occurrence of the event, goal or misses, and try to infer this probability. Our data is in 0 and in 1. So we are going to find which is the best sigma function. There are infinite sigma functions that can adjust our data. So we're trying to find which one is the best one. So this is the formula for logistic regression. This is the formula for the sigma function. And this is our data. For example, one shot with 5-degree angle was a goal, and another shot with 35-degree angle wasn't a goal. Imagine that I choose two coefficients, like this one, okay? W0 1.2 and W1 minus 0.07. If we calculate the probability, we will have these probabilities. And we can make infinite models. This other model with different coefficients is going to give me different probabilities. Which one do you think is better? The second? Everybody agrees? It seems that the second one is better because when it's goal, it's giving higher probability, and when it's in goal, it's giving lower probability, right? So the logistic linear regression model tried to maximize the likelihood estimation, which is a simple function. The product of these probabilities, when it's a 1, when it's a goal, is the probability itself, and when it's at 0, is 1 minus the probability that the model is giving. So if we make this product of probabilities, we can select which one is better. But probably this is not the best one. So if we maximize this function, we will select the parameters, the coefficients that maximizes this likelihood. That is the best model for predicting probability. So that is how logistic regression works inside. I hope that is clear, more or less. So if we use our variables, we have a different coefficient multiplying every single variables. The distance, the angle, the opponents in the cone, the distance to the near opponent, et cetera, et cetera. However, this model doesn't give real probabilities since we have trained it with a balanced data set, okay? If we, once the model is trained, if we, for example, collect all the shots that have, according to our model, 80% probability, we will see, for example, 100 shots with 80% probability. And if we measure how many of these 100 shots were actually goals, we see that only 40% of them, only 40, were actually goals. So our model is not giving real probabilities. And that's because we have balanced the data set. And if we do this with different examples, we will see that our model is not giving real probabilities, and we need real probabilities. So in this case, we need to adjust, to calibrate our results in order to put the points into this diagonal dashed line. Okay, so we just go from uncalibrated probabilities to calibrated probabilities. And with this, we end our model. Let me show you some examples. Okay, in this example, we have these variables, 11 meters to the distance, 10 meters to the goalkeeper, an angle of 32 degrees, 3 opponents in the cone, and the probability is 13%. Another example, so that you can see that we graphic this not only on goals, but with any play. In this case, it's a nice save by the goalkeeper, and the probability was 45%, so it was high, but the goalkeeper saved the shot. Okay, so these will be the variables in this case. Another example, so you can see that we can put this not only with shots, but wherever we want. In this case, the player is going to carry the ball, but if he had shot from there, he will have 8.8% probability. But he continues to carry the ball, and he almost doubled its probability. Okay, so we can make interesting use cases when graphic this probability. So if he had shot on this position, the probability would have been 8.8%, but he decided to continue to the goal. He decreases the distance, he increases the angle, so the probability almost doubled. And to end, let me show you an example in which I want to need your help again. I need you to tell me two things. Let's take the video first. Okay, first question. Do you think it's a goal or a miss? He's alone in front of the goal. That's the first question. Second question, which is the probability? 80? He's alone in front of the goal. Should be 100%. Some people say that, okay? That's why I'm showing you this case. It's a tricky shot, yeah. But it's interesting because for fans, they say that this kind of shots should be 99% or 100%. And we teach them that it's not, that it's very difficult to score in football, okay? If we put this probability, it would be 72%, right? And let me show you what happened. He misses, okay? So this happens a lot in football. Players miss shots that are really easy, but they are not. So the model also learns from that. And with these particular shots that players miss, the probability goes down. So it's very difficult to score in football. And it's interesting that for fans, they think, many of them, they think that the probability should be higher. So it's interesting to demonstrate that it's not, okay? The model works very well, and the probabilities are very accurate. And it's a different perspective for the fans. They understand the football in another way. Okay, so that was it. I would love to mark the end of this presentation with the reminder that we at LaLiga Tech, we can do this not only with football, but with basketball, with baseball, with tennis, and any sports that comes to mind. You name it, and we can provide the most precise predictions as well as content and fan management in the market. So thank you very much. We have a few minutes for any question that you may have. Be gentle.
Great presentation. Did you also consider a feature for the quality of the goalkeeper or the defense?
No, because this is a probability of the player itself. It should be interesting, taking into account these factors, but we only consider the probability that these players have regarding any other circumstances about the opponents. So it's only for the player. We could have this one, but this is not given in the tracking data. This is an event data, okay? So we don't have this in real time.
So here.
Okay.
Can you share the most important variable for the model?
The most important is the distance to the goal. We have write a paper about all this, and I can share you one. You can contact me on LinkedIn, for example, and I can share all the information.
Thank you. Thank you, Rafael. Very interesting presentation.
Thanks.
Have you thought any potential ways to improve your model, like weather, for example?
I don't know if weather should be an interesting variable for this case. But yes, we're trying to improve the model, considering different circumstances, like, for example, if the height of the ball, the speed of the player. We are going to improve this model. I don't know if we'll include the weather, but of course, if it's snowing, the probability should also decrease. But in Spain, the weather is not very different from the year, so I don't know if this will affect the model.
Okay, thank you.
Thank you very much. It was a great presentation. I love it. And have you thought about the speed of the ball and also the speed of the player? Because at the last thing that you showed, I think the reason that he couldn't make it a goal, it was the speed of player and the speed of the ball.
Yes, the problem with these variables is that they have many errors because now they have improved it because they changed the cameras, and the optical cameras are in the 5th generation and they are better. But with the historical data, these kind of variables have a lot of errors. So we have tried to include it in the model, but we saw that didn't help. But in the future, probably when we collect more data, more historical data, probably we will include the speed of the player, the speed of the ball, and also the height of the ball.
So oftentimes I saw that after a game, you see the number of expected goals based on the statistics for both the teams. But if you take, when computing these metrics, if you take into account the quality of the players, and if Barcelona plays Levante, they will actually have more expected goals because their players are assumed.
Yeah, this is different from expected goals. This is only for the broadcasting, for the fan to understand the probability. We also implement the expected goal metric, and we provide to the clubs, but in this case, we don't take into account the quality of the player.
What's the division of labor between Stats Perform and LaLiga Tech?
Stats Perform basically is the provider of the event data.
But it's all your proprietary models that are operating on top, that are working on top of this data.
Yeah.
Thank you.
Lots of questions.
Yes.
All right, let's do maybe 2 more and we'll wrap that up. But if you guys have more questions, I'm sure
we'll be around.
Rafael can answer them at the back of the room.
I love
it. When assessing the quality of the player, how far back in his history do you go? Like, is it all time, other leagues?
No, it's the past 2 seasons. And we only consider players that make more than 10 shots. So imagine that a player makes 1 shot and scores. It's not taken into account because we need at least 10 shots in order to cluster in these players.
Yeah, thank you for the presentation. It was great. In terms of the metrics, you mentioned 4 of the use cases. Where does that demand come from for new metrics, and how does that?
The what?
The sort of the demand for a new metric, so like XG or goal probability. You mentioned some use cases of different statistics. Where does that demand come from? Is it sort of a LaLiga thing? We say we want this new statistic. Is it a club-led thing? How does that sort of happen?
This metric was developed for only the broadcast of the matches, but we also had a model for expected goals. This is different goal probability and expected goals because of the quality of the player. So there are different metrics. This is only for the broadcast and for the fans to get close to this kind of statistics and to see the football in other way. But we also calculate the expected goals, and we provide this information to the clubs so they can see the cumulative expected goals and compare the performance of his player with another team. So.
All right, thank you.
Thank you.